In this video, we're going to learn how to factor polynomials of quadratic form. So looking at this question, it can look a little bit complicated and maybe more complicated than any normal type of factoring you've ever done. But we can simplify this very easily. And I'm going to do that by writing a let statement. So the first thing I'm going to do is I'm going to say let r equal x plus 2. And that's because I have an x plus 2 here, as well as an x plus 2 here. So just to simplify it, I want to replace both of those x plus 2's with an r. What that's going to do is it's going to turn my question into 12r squared plus 24r plus 9. So it's already made this question look a lot simpler. And it looks like a trinomial now. It's a complex trinomial. So now we're looking at how do we factor this complex trinomial? Remember, the first thing you want to ask yourself is, are 12, 24, and 9 divisible by any of the same numbers? And 12, 24, and 9 are all divisible by 3. So the first thing I'm going to do is I'm going to factor out a 3. And that's going to turn this into 4r squared plus 8r plus 3. So it's just taken my question and made it a little bit simpler. Now I'm going to factor it using MAN. This is a complex trinomial, which means for the multiplication portion, we need to multiply by 3 times 4, which is 12. So we need to multiply to 12, and we need to add to the middle number, which is 8. The two numbers that work in this case, factors of 12 that work, are 6 and 2. They multiply to 12 and they add to 8. So my two numbers are 6 and 2. I'm going to put those back in the equation, replacing my 8r with 6r plus 2r. So that's going to turn this into 4r squared plus 6r plus 2r plus 3. And then I'm just going to split this down the middle, look at the last two terms separate from the first two terms. And I'm going to think, what is common between my first two terms and what is common between my last two terms? When I look at 4r squared and 6r, they both have a 2r that's common between them. So I'm going to factor that out, which will turn this into a 2r plus 3 is what's remaining. And when I look at my last two terms, they have nothing in common, just a 1. So I'm going to write it as plus 1, 2r plus 3. Now remember, coming up with my brackets for my next line, my first bracket is the common bracket between them, which is the 2r plus 3. And my second bracket will be everything that's left over. So we have 2r plus 1 left over here. So now we factored our problem, and we can replace our r with our x plus 2. So don't forget to do that. We did change it in the beginning. Let's change it back. So instead of writing r, I'm going to write x plus 2, which makes this problem 3 times 2x plus 2 plus 3, and then 2 times x plus 2 plus 1. So I'm now going to FOIL this through, multiply the x by the 2 and multiply the 2 by the 2. Same thing here. The x and the 2 both get multiplied by the 2 outside of the brackets. And that will turn this into 3 times 2x plus 4 plus 3 and 2x plus 4 plus 1. So my final answer here will be 3 times 2x plus 7 multiplied by 2x plus 5. So remember the steps in this problem. The first one is we're going to simplify the problem with our let statements. So we replace the common brackets, the x plus 2, with another variable. We've replaced it with r. That gave us a complex trinomial problem that we simplified a little bit by factoring out the 3, and then we factored it like a complex trinomial. And when it was fully factored down here, we put our r back in. So our r was x plus 2. We subbed it back in for r, and then we were able to expand and simplify. Let's look at another example. This one's going to be a little bit different, but we were told to factor these two things. So what does this look like? We have 16, which is a perfect square. X squared plus 1 squared is a perfect square. 4 is a perfect square. And 2x squared is also a perfect square. So here we have two perfect squares, and they're separated by a negative sign. So that tells you right away that this is going to be difference of squares. But before I get into factoring this, I actually see something common between those two. So 16 and 4 are both divisible by 4. So I'm going to start this problem by factoring out the 4. So I'm going to turn it into 4 times 4x squared plus 1 squared minus 2x squared. So I'm factoring out that 4 just to make it a little bit simpler. It's still a difference of squares problem. And then, because it's a difference of squares problem, I'm going to look at what is the square root of my first term. So what is the square root of 4x squared plus 1 squared? The square root of 4 is 2, and x squared plus 1, because that is squared, the square root of that is just x squared plus 1. For my next one, I have 2x squared. And I'm going to take the square root of that, which just cancels out the squared. So the square root of 2x squared is just 2x. Then we can plug it back into our two brackets. So we have 4 in the front. Our first bracket is going to be 2x squared plus 1 plus 2x. And my second bracket is going to be 2x squared plus 1 minus 2x. And now it's just about simplifying. So to simplify this, I'm going to multiply in this 2. So multiply both terms by 2. And same thing here. Expand out that. So my next line is going to look like 4, 2x squared plus 2 plus 2x. And my other bracket is going to turn into 2x squared plus 2 minus 2x. So what I'm going to do now is I'm going to write this in trinomial order. So I want my x squared term to go first, then my x term, and then my single digit. So how I'm going to write this out is 4 times 2x squared plus 2x plus 2. And my other one will be 2x squared minus 2x plus 2. And just looking at the two brackets, they both are divisible by 2. So I'm going to factor out a 2, which will make my first bracket x squared plus x plus 1. And then when I take a 2 out of my second bracket, that will turn into x squared minus x plus 1. The last thing I'm going to do to simplify this is multiply all my numbers together. So I have 4 times 2 times 2, which works out to 16. So this is 16 x squared plus x plus 1 times x squared minus x plus 1. Now we are left with two simple trinomials. You can do a quick check to see if you can factor these further. So for the first one, you would have to multiply to 1 and add to 1. So in order to multiply to 1, the only two numbers you can use are 1 and 1 will never add to 1. So we know that this one doesn't work. You can't factor the first bracket, this bracket right here. You can't factor that one further. Let's look at our second bracket. We'd have to multiply to 1, add to -1. And same thing as before, the only numbers that multiply to 1 are 1 and 1, which you can't make add to -1. So this second bracket can't be factored further either, which means this is our final answer.